Welcome to CodehubIndia. Today we are going to do study more about the kinetic theory of gases. Yesterday you might have gone through that our all lessons and solved the problems. First of all, we have to know what is vapor pressure and the humidity. These are the very correlated to each other. Both are the interdependent with each other. So, suppose you are heating the water in a container. What is water? Water is H2O. Which are attached with the hydrogen bond and oxygen, the covalent bond. In spite of this strong attachment with each other of the molecules inside the water, that H2O, one is the hydrogen bond, which is very not so strong bond, but distance. And molecules are moving to the jet manner. This means a fraction of the near to the surface are moving enough to escape. Because at the surface area, the water is boiling. I am not talking about the wall side of the water container. I am talking about the surface area where air is attached. At that place, they have the escape velocity as compared to the molecules inside of that other places, and forming a vapor above the surface. In a closed container, if enough water present in equilibrium situation is situated between the escaping and returning molecule, look at this closed container. You might have seen a daily cooking in your home. The container, water is the middle of the container, and upper side air is covered with the plate. That is air and water vapor. That portion contains what? Not heating, there is air and water vapor. So equilibrium is the closed container. The molecule has the vapor have the same average kinetic energy as air molecule. So exert pressure on the wall of the container once till the boiling. It is seen hot. At that time, the pressure is in equilibrium. Surface is not moving. At that time, it becomes a saturated pressure. At that time, can say it as a saturated pressure. And temperature will go like with exponentially e to the power alpha t. And at the surface area, it is free for the molecules on the surface area to escape out. Where is the surface area? This is the surface area. Okay. Now, at room temperature, saturated vapor pressure is around 3.5 of the atmospheric pressure. When undoubtedly when the temperature increases, generally water boiling to place সারিয়ে देंगे, and at the boiling temperature the water bubble took place at the surface of the water in contact surface of the boiling water. And water starts to boil. We mean to say the water boil at the lower temperature in mountain, producing the infrared heat. Then what is relative humidity and dew point? If the water is constantly boiled off in the closed room, the limit to how much water vapor of the air can hold. So that the air becomes saturated faster than the air cannot consume more water. That limit depends upon the temperature. Attempt to add more water result to do condensation and form furnace. When the water vapor mixed with the air more to the saturated point of the air, that is causing condensation and dew. So relative humidity is what? That is the vapor pressure divided by saturated vapor pressure of the air. That is the ratio. And dew point, you might have understood what I told you, that above the saturated point of the water vapor mixing in the air, causing the dew point. A pressure cooker inside the pressure cooker is about 2 into 24 pascal of pressure, and vapor pressure of the water rises from 1 atom to 2 atom, making the inside from 100 to 30 because this is boiling point inside the pressure cooker. So, what are you getting? The behavior actually, what was your assumptions? Previously, I mentioned in the gas supply and control, you are running gas. The behavior of real gas usually agree with the prediction of the ideal gas equation within a 5% of normal temperature pressure. We can consider the real gas behave and follow the rules of molecular structure. In around 5% humidity of the normal temperature. At low temperature or high pressure, real gas deviates significantly from the ideal gas stream. The Dutch scientist physicist Van der Waals developed an explanation for this deviation, an equation that was able to fit the behavior of the real gas over the wider range of the pressure. Undoubtedly, the pressure will increase power, pressure will increase, then what will happen? Already pressure increase. At low temperature, power. So, assumption of the kinetic theory of gases. Kinetic theory of gases assumes that the glass particles occupy the negligible fraction of the total volume of the gas. It is negligible, it is assumed on postulating the kinetic theory of gases. It is also assumed that the force of attraction between the gas molecules is zero, but we cannot do that. If we consider the first assumption, that the kinetic theory assumes that the gas particles occupy the negligible fraction of total volume of the gas. Then what will happen? Pressure close to the 1 atmosphere, but something happened to validity of this assumption as gas is compressed. Imagine, look at this. This was the thing, and when it is compressed, then you can understand the particles its masses that will start to move in a particular narrow places. And it's called the assumption of the kinetic theory of gases. You see here, it is narrow here on compressing this different region. Clear? But at high pressure, this is no longer true. As a result, the real gas are not decompressible at high pressure in ideal gas. The volume of the real gas is therefore larger than that from the ideal gas at high pressure. How much larger? Mr. Van Waals defined the parameter of E and B. Let us check. Van Waals proposed one of the correct for that fact. Volume of the real gas is too large at high pressure by subtracting a term for the volume of the real gas before we substitute into the ideal gas. That is into number of the molecule, that volume equal to V minus NB with a constant V. Because the volume of the gas particle depends upon the number of the moles, so it is multiplied with the A. When the pressure is relatively small and the volume is reasonably large, the NB term is almost negligible. This NB term. Because V is very large at that time, and NB becomes less and less as compared to V, and we can neglect the NB and follow the what? Ideal gas formula. If NB becomes the negligible, then we follow the ideal gas formula. But at high pressure, when the volume is gas is small, then this NB will take a part of role and that is the condition of the real gas. The assumption of that there is a no force of attraction between gas particles cannot be. There will be no any force between the gas particles, so what will happen? The gas will never condense. Condense took place when the vapor pressure, water vapor pressure mixed with the air. In reality, there is a small force attraction between the molecule gets into the whole molecule together. There is no connection between the molecule of a gas. The connection will not take place. There will be addition between them. This force of addition is two concepts. The gas contains to form a liquid at low temperature, and the pressure of the real gas is sometimes smaller extended than the ideal gas. Clear? So let us think about the pressure. Because pressure into volume equal to constant. Pressure will more, then volume will be less. Volume more, pressure will less. Because multiply of both variables will cause a constant. Constant should not be changed. Should be constant value. To correct that the fact that the pressure of a real gas is smaller than the expected from the ideal gas equation, and there was term, we will include a term A for the pressure that has a form of A divided by A square by A. The volume will be deducted, the pressure will be increased. Pressure will increase. Otherwise, we can't get this constant value because we are considering the PV curve at constant temperature, and R is the universal constant, and the N is the number of moles that is also constant. So if V will decrease by AB, then P must be increased by A square by P square. This equation sometimes the mixed replacing and providing much better in the area of real gas other than the ideal gas. It does that the cost of the loss generally, and we can calculate everything from it. In the new course, we will learn how to calculate the value. Okay? So, the value of A and B have been experimentally calculated for all the real gases at A and B. When you put the value of A and B and equate the equation, what are the value of getting in the ideal gas application? That will come what is the AB if it is less. So you don't worry for that value. If the problem will come in your question, the value will be given. Okay? Value of A and B will be given. So that is explained. We have told about the B and A. Okay? Now what is equilibrium? Suppose you have two boxes. There is one red color gas, another is white color gas, separated from series. Okay? When you pull it out, the equation starts to place till the saturation of the molecules inside the both sides of the that I told you. When this time later the gas can be observed that has diffused into other, but molecules are moving at around 6 meters per second. Okay, that's called diffusion. So spin ball scenario, you might have seen the spin ball game. The gases took a long time to mix with the oxygen, and oxygen molecules say moving into nitrogen, bound like a ping ball. How much bound? What are the things we are having? So it is a tendency of a molecule molecule follow the process. The diffusion rate, to get the diffusion rate minimum, they are taking the shortest path. They are not going like this. In the shortest path, like this. The mean free path is defined as, that is called what? Mean free path. Defined as the average distance of molecule travel. That is statement path. Imagine the method of statement path, collision occurs with the another molecule. Say later, the sequence of cylinder follows cylinder of radius d. Understand? Center on that path. The path is at center with radius d. The traveling a distance L, the length of distance A, the molecule stretched out in volume, how much? That is 2 pi r L, that is what? Pi r square L, that is what? That is the volume formula, pi rho square L. Pi by 2 r square, and pi rho square. Here, this volume of stretched out, this volume of molecule has stretched out. That from here, and when it is taking out here, the total volume is stretched out of that molecule. Now consider the distance is L, molecule stretched a volume of this volume of molecule pi d square L, travel a distance. Then how much? Remember the average volume per molecule is what? In here is around 1000 into d. Clear? So therefore the molecule will hit another one on the average traveling L length, that is what? Pi d square L into d. The bottom line is that P path is the air around 300 feet. Okay? That is the molecular diameter. So, random walk. Let us consider the one-dimensional random walk. The molecule can progress with a pinball type vector path. Always try to have shortest path. And let us consider in one dimension for that one. Part of that for our simplicity. Suppose we have a clear point on average it come out in a calculation. Probability you have to know the probability. What is the probability of that? At exactly 50% of time, it is coming 50% of time, it is coming. And take a walk crossing the point of the by with a step. One step forward for the head, one step backward for the head. Head, arrive, forward, then arrive, backward. That is what 50% head. You are zigzagging in the head and head. Okay? So, one-dimensional random walk distance that what? For what I get, most likely after 100 steps, what is get? Equally like forward and backward. Of course, it is many times. What we have, most likely it will be distance from the starting point. Where you were, now was probability of the head for the point is 50%. So, if x1 say take variable x1, x2, x3 special variable to x10, then x1 is plus 1, then x2 is what? Minus 1. And similarly you will get that plus 1 minus 1 plus 1 minus 1. Okay? With equal probability. With the equal probability. Okay? We are trying to find how far away we get. We don't care which way or let's find the average speed. Average. That means what? x1, x2, x3 summation of subscript x1 to xn whole square equal to, that will apply this formula. Okay? You know the x plus a plus b whole square formula, that is the part. Similarly, x1 whole square into the binomial theorem of it, x1 whole square, x2 whole square, x3 whole square to xk whole square. Then we have to take the multiply of 2 into, since it is a 2 here, so complement 2 and we multiply every time of the fraction, that x1 into x2, x1 into x3, x1 into x4, x1 to x5, x1 to plus xk. And we will get see the like lot of cross term. Now what is the value of cross term? The x1, x2, if x1 is 1, x2 is minus 1. But x2 square minus 1 equal to 1. Clear? And that minus 1 to minus 2 minus 2 minus 2 minus 2. On the right hand side, the square term all equal 1. Clear? Because 10 term of value 1, that becomes the 10, and it is what? 5 term of it becomes 10. And the right hand side, the square term will be equal to 1. And the cross terms are equal like positive. Average is 2. And what are getting? The bottom line is that you are getting the average square distance equal to 10. That square distance equal to what is equal to sum of this equal to root over 10. What is that? That the real gas between each other, the molecule follow many different paths. So, average over the path give the good picture that distance how much in our molecule of distance say that is root over. Got it root over here. Average distance root over 10. Okay. So root over 10. Okay, and what will happen? We are having that tribal velocity is 500 meters per second in here at 2 temperature. This means that at time t we travel how much? dt distance. They will move dt in random state of length L. Okay? That in any state n equal to v by n. Okay? Then what I got? Distance reduced in time t is r equal to root over L, and what is L? H value is root over principal L. Okay. And what we got? That if I got if you take each side of the root, this L, then this becomes x square, and the square is cut to the lower side and become BTN. Clear? So, actual difference between this kind is r equal to root over NL, that is BTN, root of BTN. That follows the Avogadro number. That's how. According to we got the Avogadro number.